Hello greetings, welcome back to another video. So in today's video we'll be doing state of matter and the kinetic molecule theory. So in the previous video, which is part 1, we did what is matter. Yes, I dealt with what is matter. Now in this video part 2, we'll be doing state of matter and the kinetic molecule theory. Don't forget to like, comment and subscribe to the channel for more of these videos. And without wasting any more of your time, guys, let's just get right into it. Now we're going to talk about the state of matter and the kinetic molecule theory. I'm waiting for this to focus. So all matter is made up of particles, and we can see this when we look at diffusion. So you need to know diffusion. Diffusion is the movement of particles from a high concentration to a low concentration. So if you are in a bottle, you have a high concentration of orange juice. When we're trying to decrease the concentration of the orange juice, that is a process of diffusion. Okay, diffusion can be seen as a spreading out of particles resulting in an even distribution of the particles. So you can see diffusion when you place a drop of food coloring in water. The color slowly spreads out through the water. If matter were not made of particles that are constantly moving, then we would only see a clump of color when we put the food coloring in water. So because matter is made up of small particles, that's why they fill up the glass. Okay, so a concentration, a orange juice is a concentrate. Now if you put water inside that orange stroop, the concentrated juice, you get what you call diffusion. Diffusion. Okay, so you have decreased the concentration of that concentrated juice. So diffusion is a result of a constant thermal motion of particles. So that is the diffusion. That's what you have to know. And then we also need to know melting point, the temperature at which a solid changes its phase or state to become a liquid. The process is called melting. So you need to know that. You need to know the freezing point as well. Is the temperature at which liquid changes its phase to become solid. The process is called freezing. And then you need to know evaporation, the temperature at which a liquid changes its phase to become gas. The process is called evaporation. And then you need to know condensation is the process of going from a gas to liquid. And then sublimation is the process of going from solid to gas. The reverse process is called deposition. So we're going to look at this diagram here. Very important, guys. Very important. So when you have gas and you're going to liquid, is condensation. But when you go from liquid to gas, it's boiling or evaporation. Now when you're going to liquid to solid, it's freezing. But from solid to liquid, it's melting. And then when you go from solid to gas, is sublimation. Okay, so familiarize yourself with this. There are 3 states of matter, which is the liquid phase, the solid phase, and the gas. So we go from liquid, the water is it's solid. When we are freezing, let's say we're doing the freezing point, so we're going to do a heating curve. I'm going to write it. This is going to be our heating curve, and then this side we have temperature, and then we have here we'll have minus 20, and then here we have minus 10, and then here we'll have 0, and then here we'll have 100 degrees is all degrees, and then here we will have maybe 110, 20 degrees. Then we will have here this time we will have time, and then in the x-axis, so these are the x-axis, this one are the y-axis. So here we'll have 5 minutes, 10 minutes, 15 and 20 minutes. Okay, so here this is 0 minutes. We're starting where? We're starting at solid. So here we're starting at solid from 0 until 5. Okay, so you start first at 0, whereby you have a solid phase, you have ice. This is ice, so that will be our solid phase. So the energy from A to B, here at 0 it will be A, and then at 5 we have B. Okay, so from A, which is here at 0, is the A phase. Let me change the color. From A to B, energy, again, we have put the pot on the stove. It's an ice inside that pot. So we put it on the stove, we light the stove on, and then energy is starting to enter the system. It's being used to increase the kinetic energy of the molecule. So the kinetic energy of the ice is increasing. The ice starts reacting to the hot surface underneath. That's what is happening there. So the ice inside the pot is starting to react to the heat that is coming underneath from the gas stove. So that in that from A to B, we say energy entering the system is being used to increase kinetic energy of the molecule. Okay, so that is from A to B. Then that will happen like that until 10, and then at 10 minutes we will call that 10 minutes C. So melting energy is entering the system, is now being used to overcome intermolecular forces. It is now being used to increase the kinetic energy, and the temperature becomes constant. So at B to C, now the ice is beginning to melt. Okay, beginning to melt. The intermolecular forces are increasing, so which means the particles inside the liquid, you are not having liquid, are starting to move. At solid phase, the particles are not moving, but in B to C, now the particles are starting to move and show some movement. So at C, we now in the liquid phase, and then we will go up to 0 degrees in 15 minutes. So at C and D, energy entering is used to increase particles. Okay, so the particles are just increasing from C to D. We are where it's the water is now beginning to increase. The water is beginning to melt drastically at point C. We are now in the liquid phase. It's hot. The water is hot. Not hot, sorry. It's super cold. It has melted, but the water is still very, very cold at C. And then that happens from C until D. And then at D, now it will go up. The water is beginning to get hot. Okay, now the increase in temperature begins. Now the water is boiling. Energy entering is being used to overcome the intermolecular forces. So energy is now being used to increase kinetic energy. Kinetic energy, anything that moves has kinetic energy. So the particles inside the water molecules or particles are starting to move. So kinetic energy has increased drastically. The water is starting to boil. Okay, so this is D, and this is number E. So the water is starting to boil. So at D and E, temperature remains constant. The temperature is constant. And then when the temperature gets to 100 degrees, it does not go up. The temperature remains the same during the boiling point, and the particles become gas. Now, at the gas phase, we are now going to C and F. We are now at the gas phase. Energy entering is now used to increase the speed of the molecules, and temperature will increase. We are in the gas stage on E and F. So here we just explained the heating curve, and then we also have what we call the cooling curve. So from the heating curve, we are going from solid to gas, but for the cooling curve, we are going from gas to solid. So with the cooling phase, we are going to start here at 120. We'll come from 120 till B. So we are in the cooling phase. Okay, so 120 will be A, and then 100 will be B. Here we'll get B. So particles are losing energy, and therefore the kinetic energy decrease from gas stage. Okay, and then from B, we will go to C here, and then in C is condensation. Condensation is happening at this stage. Particles are creating stronger intermolecular forces that releases heat. This release of heat balances the energy lost due to cooling. So the temperature remains constant from B to C. And then from B to C, we go from C to D. We go from C to D. And at C, again, we are at liquid phase. We are no longer on gas. Ne? The liquid is aware that it can now turn to a solid, so the intermolecular forces become stronger. Because the intermolecular forces are forces between the H2O molecules, so they're becoming stronger. We have many H2O's molecules inside that makes water, so their bond becomes stronger. So those intermolecular forces, those H2O molecules are becoming tighter together. So it means that's why we say intermolecular forces become stronger. So they become tight together. The intermolecular forces in liquid are tight, and then they are joined together. In liquid phase, they're starting to move, but in gas stage, they are wide apart. Okay, so from C to D, condensation is happening, is the liquid phase, and then we will go from D to E. And then in D to E, energy that is lost due to cooling is balanced by the energy released in the system when stronger intermolecular forces are being created. Therefore, temperature remains constant at D to E. E to F, the particles will continue to lose kinetic energy. Temperature will decrease. Now we are at the freezing state. Okay, so when you ask this in the question, you'll be asked maybe what is happening at B, what is happening at C, what is happening at D, what is happening at E, and what is happening at F. That's how this question will be asked. So you have to know the different stages of the cooling and the heating curve. So we use the kinetic theory of matter to help us to explain why matter exists in different phases. Okay, solid, liquid, and gas, and how matter can change from one phase to the next. So matter can change from one phase to the next. The kinetic theory of matter also helps us to understand other properties of matter. It is important to realize that we will go on to describe is only a theory. Okay, it can not be proved beyond doubt, but the fact that it helps us to explain our observations of change in phase and other properties of matter suggests that it probably is more than just a theory. So we use it to explain the three stages of matter. Can you see in solid, the intermolecular forces are strong, and those balls are tied together. And then in liquid, the intermolecular forces are not strong, but in gas they are extremely weak. The intermolecular forces, those particles are far away from each other. So the kinetic theory of matter says that all matter is composed of particles which have a certain amount of energy, which allows them to move a different speed depending on the temperature. So there are spaces between the particles, also attractive forces between particles when they move closely together. So in solid, the attraction is high. In liquid, starts to decrease, but in gas, it's very, very low. Now let's look at this, the property of matter. We have solid, liquid, and gas. How are the particles? We're going to look at the properties of matter are particles, energy and movement of particles, space between particles, attraction force between particles, and change in phase. So for the liquid, atoms of particles, atoms or molecules. In liquid, the particles are still atoms or molecules, and in gas, the particles are still atoms or molecules. Energy and movement of particles, it's low in solid. Particles vibrate around a fixed point, and then in liquid, particles have more energy than in the solid phase, but less than in the gas phase. And then in the gas phase, particles have a high energy and are constantly moving. So speed between particles, very little space between particles. Particles are tightly packed together, and then bigger space than in solid. That is how you do it. And then we do attraction forces between the particles. They are very strong in solid, weaker in liquid, and weak force because of the large distance between the particles in gas. And then change in phase. Solid becomes liquid or gas if their temperature is increased. A solid becomes a gas if its temperature is decreased. So that is what you have to know for your tests. Okay, so we did 3 states of matter, and then the here is a summary that there are 3 states of matter: solid, gas, and liquid. We have diffusion, melting, freezing, evaporation, boiling, sublimation, the kinetic energy theory of matter. And then the kinetic theory of matter says that all matter is composed of particles. So that is a summary of the. So now we're going to look at steps of writing the chemical formula. So when you are given a chemical formula, you need to know how to write that chemical formula. Okay, so step 1, you look on the periodic table to check the elements valency. Number 2, you put together the ratio, and number 3, you simplify the ratio. So we are going to let's write the formula of NaO. So we are going to write the chemical formula of NaO, which is sodium and oxygen. The Na is sodium and O is the oxygen. So we are going to try to write its chemical formula. Before we do chemical naming, I think I should do it in the next video, because before we move on to that one, you need to know the periodic table first, how to use your periodic table before we can move to that part. So let's look at this. This is your periodic table. So these ones that are colored in gray, we have your metals. Okay, those are all your metals. So you have to color your periodic table that those gray ones are metals, and then the green ones are your non-metals, and then those light blue ones are your metalloids. So you need to know. And then the answer 1, 2 and the top shows the group. Okay, that is the group. H, which is hydrogen, is in group 1, like that. And then 14 is carbon. So and then what another thing that you have to know is that you need to know that these first two blocks are in the S blocks. The ones that are in the middle are in the D blocks, and then these ones that are in your far right are in the P blocks. That's another thing that you have to know. And then you have to know the electronegativity from 1, 2 going down, counting the blocks going down. 1, 2, 3, and 4 are electronegativity, and then 5 is ionization energy, and then 6 and 7 is atomic radius. And then another thing that you have to know is the this group 1, we have alkaline metals, and then group 2 we have alkali earth metals, and then we have transitioning metals, that one that is in the middle, and then we have group 13, 14, 15, and 16, and then we have halogens, and then we have noble gases. Noble gases are fully surrounded. They have 8 valency electrons. Okay, so this one is the groups going up. So that is how you have to look at your periodic table. You can make a copy of your periodic table and make this notes for you to know, guys. So the following diagram illustrates some of the key trends in the groups of the periodic table. So the atomic radius goes down, ionization energy goes up, electronegativiity goes up, melting and boiling is up, density is low. So you need to know all those things. And then another thing, a few points, is that although hydrogen is the H appears in group 1, it is not an alkali metal. So group 15 elements are sometimes called nitrogens, and then group 16 elements are sometimes called halogens, and then the halogens and the alkali earth metals are also creative groups, noble gases, unreactive. So those are the things that you need to know with your periodic table. Yes, so you need to know atomic radius, ionization energy, electron affinity, electronegativity. A group of a vertical column is the vertical column in the periodic table, and is considered to be the most important way of classifying the elements. And then a period is a horizontal row in the periodic table of the elements. The periods are labeled from top to bottom, starting with 1 and ending with 7. So those are very important things that you need to know with the periodic table. So this is the periodic table. You just use your pencils, your colored pencil, to draw and make notes on it. Make a copy of it, and then you can be able to know what is what and what is which. So until the next video, where we'll be doing electron configuration, Lewis diagrams, we'll be doing all those things, how to name the chemical formula, how to name, how to write the chemical formula, and how to name it. So it will just be filled with a whole lot of practical things, no theory on the next video. So the same day next week, let's meet right there, guys. Until the next one, thank you.